Assalamualaikum and welcome to our group presentation. So from group 1, this is our project which is Power Usage Analyzer. So group 1 in section 3, this consists of 5 members which is Cassandra Kajan, Awang Muhammad Afiq bin Awang Ali Mat, Ahmad Syafiq Adam bin Adnan Kameng, Bennett Philip anak lelaki Raymond Francis, and Abang Izrul bin Abang Ahmad Termida.
Introduction of Power Usage Analyzer. The study highlights the importance of optimizing energy consumption in buildings in response to growing urbanization, escalating costs, and environmental challenge. It identifies lighting appliance and HVAC as the main energy-intensive system. A computational model is used to, first, calculate total energy consumption based on users' input. Second, classify energy efficiency into high, moderate, and low categories. Third, suggest tailored optimization strategies. The goal is to establish a structured method for energy analysis and optimization to enable smarter energy management practice. Background of the project. Energy efficiency is vital, but achieving sustainability in building is challenging. Lighting, HVAC system, and appliance often waste energy due to outdated tech or poor management. Computational tools help by reducing costs, cutting carbon emission, and improving system efficiency. This project developed a Python tool to analyze energy use and provide insights, efficiency classification, and energy saving recommendation. The goal is to help building owners save energy and make informed sustainability decisions.
Here the problem statement. Building consume a lot of energy, primarily due to light, HVAC system, and appliance, and many still waste energy despite advancement in energy efficient technologies. Second problem is current energy analysis methods are often insufficient, failing to identify specific problem or offer clear recommendation based on unique energy use pattern. The third problem is the main issue is absence of a systematic, easy-to-use tool that accurately measure energy use across key systems. Identify inefficient by clarifying system efficiency. Provide actionable recommendation to improve energy use. So the project aims to develop a computational tool that combines measurement, clarification, and recommendation to simplify energy use analysis and optimization. For the solution plan for energy consumption crisis code, this project aims to develop a Python program to analyze and optimize energy used in building. It focuses on measuring energy consumption, categorizing efficiency, and providing simple improvement tips. The program considers factors like energy demand for light, HVAC system, and appliance, along with operating hour and efficiency level to offer an easy-to-use tool for smarter energy management. Plan for developing the energy analysis program. The program will focus on individual building and domain energy using system. By studying energy use pattern, it will provide insight into efficiency level and suggest ways to save energy and reduce environmental impact. Here the input and the output. So the input is the first one is number device type, energy consumption of device in volt, hours of operation, cost per kilowatt per hours in Ringgit Malaysia. So the output will be device type, the total power consumption for a day, total electricity cost for a day, RM, number of high power device, suggestion for optimization such as reducing usage or upgrading device.
These are the development steps. So the first one is the input data collection, the design of system to accept user inputs for energy demand, or the operational hours and efficiency. So number second is the energy consumption calculation. It will use the formula of total energy kilowatt hour equal to the demand, which is kilowatt hour times operating hours time efficiency percent over 100. So it is automate the calculation for each input data set. So number three is a optimization strategy suggestion, which will recommend the action of strategies such as the reducing lighting or appliance usage if the limits are exceeded. It also optimizing HVAC setting for improvement and efficiency, and it will suggesting energy efficiency upgrades from appliance. And number four is an output presentation, which is it will display result for each test case, including the total energy consumptions for a day, total electricity consumption for a day, efficiency classifications, and suggestion for optimization. And the last one is a user interface design, which is to ensure the outputs are clear, short, and easily understandable by users. Hello, my name is Ahmad Shafiq Adam, and today I'm going to present about the flowchart. So the first one is start, and then we insert the input, which is the number of device, device types, device voltage, usage time, voltage limit, and cost per kilowatt hour. And then the process is to calculate total daily consumption, count high voltage device, count total daily cost, and check device voltage. So and then we go to the decision, which is a device voltage. If the device voltage more than 1000 kilowatt hour, and then it will print this device is not energy efficient. If no, and then it continue to the print total daily consumption. And the other one is the check usage time. If it's exceed the 8 hours, it try reducing hour for this device, and if not, it's print remember to turn off this in hour. So you're gonna both of the decision will print total daily consumption, and the print toss total daily cost, and then it also will suggest the optimization, device voltage, usage time, and device unit, and then it will be end.
My name is Bernard Philip, number metric DD230036. This is the complete program codes. As you can see, there is three functions. In each functions, there is for loop and also a single return. For example, for the function of suggest optimization, we can see a for loop for k in range of land device voltages, and if device voltages is more or equal to 1000, it will show that this device is not energy efficient. Consider replacing it with more efficient model. Elif, within the hours of 24 and 15, it will show that try reducing usage hours for this device. And Elif, usage time is equivalent to 0, meaning that the device is not used. It will show remember to turn off this device when not in use. And else, if everything is order, everything is good, it will print out this device is energy efficient, good job. This is the continuation of the code. As you can see, there are few inputs. So the first one is number devices, where we enter the number of device we are going to calculate. And there's three empty arrays. There's device types, device voltage, and usage time. As you can see in the for loop, we have to enter the device types, the power, and the usage hours for each devices. For the device types, we just input the name of the device, and for the power of the device, and the usage time for the device. And after that, the voltage limit. So we enter the power voltage limit in order for the code to calculate the amount of high power devices. For cost per kilowatt, we enter how much is a cost per kilowatt. Once everything is entered, inputted, it will calculate it by using the total daily consumption calculate the total consumption of the device by using the the functions of calculate total consumptions, and for the high wattage count, the high devices, and for the total daily cost is the total daily consumption times the cost per kilowatt. And you will print out the device types, the total power consumptions, the total daily cost of power, and the number of high power devices. This is the inputs and outputs for the code. First, we enter the number of devices. Then the user have to enter the power rating, usage hour, and device types for each device. Then the user have to enter the power limit for high wattage devices. This is where we can count the number of high power devices. Then enter the electricity cost per kilowatt. Once that is done, the output is the device types, the total daily power consumption, the total daily cost of power consumption, the number of high power devices, and the suggestion to optimize your power usage.
My name is Cassandra Kajan. My metric number is DD230027. And now I will present step use the code in our project for our project. First is open the program using software pattern. Second, input the number of devices. Third, for each device, input the device type, device power, and use hours. Four, input the limit of power limit for high voltage devices. 5. Input the electricity cost per kilowatt hours. 6. The program will display the device type, total daily power consumption, and total daily cost. 7. The program also displays suggestion to optimize the power use for each device.
These are the calculation and the formula. The first one is the input values. So first the number of rating is 3, and the device detail is for device 1 we put power rating 800 watts, usage hours is 7 hours, and type is lighting. And device 2, the input is a 2800 watts, the usage hour is 12 hours, and the type is HVAC. And device number 3, the power rating is 2800 watts, the usage hours is 12 hours, and the type is HVAC also. So here are the calculation that involve, which is the first one is the power consumption. So we calculate the power consumption for each device. So how we calculate it? How we calculate it by the power rating watt times usage hours H. So it will divide it to 1000. As you can see, the first device 800 watt times 7 hour divide by 1000, it will get 5.6 kilowatt hour. And the second one also we use for HVAC the same formula, and it will get 33.6 kilowatt hour. And the third one for appliance consumption, the same formula, which is 1000 watt times 8 hour divided by 1000, it will get 8 kilowatt hour. So from this calculation, we get the total consumption equal to the device 1 consumption divided plus device 2 consumption and plus device 3 consumption. So the total consumption is 5.6 kilowatt hour for device 1 and 33.6 kilowatt hour for device 2 and plus 8 kilowatt hour for device 3. It will get a 47.2 kilowatt hour. So the total cost, how we calculate the total cost is by total consumption time cost per kilowatt hour. So the total cost here 47.2 kilowatt hour for total consumption. We are with times with 20 cents, which is the price for cost kilowatt hour we get from internet TNB, which is average of 20 cents cost for per kilowatt hour, and it will get 9 ringgit 44 per day. Thank you.
For conclusion, the energy analysis program developed in this project effectively demonstrate how computations tool can assess, categorize, and optimize building energy use. It focuses on key systems like lighting, HVAC, and appliance, offering an easy way to identify inefficient and provide actionable suggestions for reducing energy waste. The program helps both resident and commercial building owner improve energy management decision by combining automated calculation with user input. Limitation. The program has several limitations. First, lack of evident analytics. The tool does not support advanced features like predictive modeling, machine learning, or real-time energy tracking. User depends data. The program relies on user-provided data, which can affect the accuracy if the information is incorrect or estimated. Third, single building focus. It analyzes one building at a time and does not account for energy interaction between multiple buildings or systems.